Early scientific findings from the Juno spacecraft show a world of intricate clouds, intense magnetism, and a potentially eroding core. The solar system's biggest planet just keeps getting more spectacular and more confoundingly mysterious. While we've known for centuries that Jupiter is snuzzily decorated with colorful, cloudy bands and stormy splotches, the images coming back from NASA's Juno spacecraft, which has been orbiting Jupiter since last July, reveal filigree clouds unlike anything else in the solar system. Now, early science results from the Juno mission, reported in 46 papers published today in Science and Geophysical Research Letters, are also painting a picture of a planet that doesn't work the way scientists thought it would, from the tops of its clouds to a potentially oversized, eroding core. I think everyone expected we would learn a lot, but I don't think any of the science team expected that every aspect of Jupiter would hold these profound surprises, says Scott Bolton, principal investigator for the Juno mission. Gathered during Juno's August 27 science orbit, the early results include the revelation that Jupiter's magnetic field is nearly twice as strong as expected, and that enormous cyclones erupt and swirl near the planet's poles. Still more data suggests that the planet's core may be larger and more dilute than anticipated, with heavy metals and rock slowly dissolving in a layer of liquid metallic hydrogen. Juno also caught a glimpse of the powerful auroras that glow near the poles, which are curiously devoid of cloudy bands, and are instead roiling, pastel-colored messes of storms and spirals that look very different from each other. And when it peered into Jupiter's atmosphere, the spacecraft detected ammonia welling up from deep within the planet's gassy shroud. The pungent, suffocating plume of gas could be creating vast weather systems that transform the planet's clouds into the artistry that we can see. I love the way Jupiter's poles look in our image is so beautiful and so very different from Saturn, says Candy Hansen of the Planetary Science Institute. We are so used to seeing Jupiter's belts and zones. Not seeing that structure at all at the poles really threw me at first. Stormier and more colorful than neighboring Saturn, Jupiter is also so much bigger that it's possible it's being shaped by processes that are more star-like than planet-like, Bolton says. As Juno loops around Jupiter several dozen more times, it will continue answering questions that couldn't even be predicted. And perhaps, by the end of the mission, the spacecraft will finally help scientists solve the mystery of what really lies beneath those twisting clouds. Jupiter is even weirder than we thought.